Okay, this is a recording of Notes for 4-7. Either we've gotten to this point on Wednesday and then this is just the rest of the lesson, and if not, then this will be, there will be a little section that you'll have had to watch first, and then you'll be watching this one. So the next part, now that we have the law of sines and the law of cosines under our belts, the next part here is to find the areas of oblique triangles. And I will tell you that in my life, this is a question that people have asked me and or my husband, because we're both math teachers, when they're doing gardening or building something, and they need to find an area, and they just have the three lengths of the sides. And our traditional formula is 1/2 base times height for the area of a triangle, but this is a formula that allows us to just know the three sides and then find the area based on that. So it's called Heron's formula, and here's what it says essentially is just that if the measures of the sides of triangle ABC are little a, little b, and little c, then the area of the triangle is equal to the square root of s times, in parentheses, s minus a times s minus b times s minus c. And then s is a plus b plus c divided by 2. And so little trickiness there, just realize it's not the average of a, b, and c, it's a plus b plus c either divided by 2 or multiplied by 1/2. So generally I say that s is a plus b plus c divided by 2. So if you know Heron's formula, it's very easy to find the area of a triangle. Area is the big square root of s times s minus a times s minus b times s minus c. And since we've done the law of cosines, this is a situation where, you know, we're in a law of cosines situation if we wanted to find those angles, and we could certainly do that and then figure out some other things from there. So this is a very straightforward problem. Find the area of triangle ABC to the nearest tenth. We have no angles that we know about. We have the lengths of three sides. So we're going to use Heron's formula, and to do that, we're going to first find S, which is a plus b plus c, so 44 plus 47 plus 53 divided by 2, or 1/2 of all of that. Be careful on a calculator if you're doing this, and you're probably all very good at that, but don't just go 44 plus 47 plus 53 divided by 2. You have to get that answer of the sum before you do that. So S equals, when we add those up, we get 144 divided by 2, or half of 144, so S equals 72. And then it's just a matter of finding the area. So the area is equal to big square root 72 times 72 minus 44 times 72 minus 47 times 72 minus 53. And, you know, your calculator can handle, I'm going to just make that subtraction sign look a little better. Your calculator can handle typing in that way, or you can kind of figure those out and get those and then figure that as you go. So 72 times 28 times 25 times 19. And so A is approximately 978.6 square feet. And so that's the simple Heron's formula that we can use as we go. So the big thing with Heron's formula is just remembering to be able to look at what it is as you go. Now, I have a picture of a triangle here because I'm just going to remind you of kind of the old way of finding that 1/2 base times height. And so imagine for a moment that we have to find the height of this triangle. And so I'll draw that in kind of as a dashed line, that height. And we talked in an earlier problem about how to find that height. if I know this angle A right here and I know this side length B right here. So I know those two things kind of going into this. And maybe I also know this length along the bottom here, which would be maybe that traditional base. And so I want to use that old formula that's 1/2 base times height. And so the base is this little c, the height is h, but we want to be able to figure out in terms of the three things that I have boxes around. So we're just going to remind ourselves that if I just look at this piece of the triangle, or this little right triangle here, I've got angle A. This is the opposite side. This is the hypotenuse of this little right triangle that I just drew in here. And we know that the sine of A is equal to the opposite over hypotenuse, or h over b. And so b sine A is equal to that height h. And so if you think of that old triangle formula for the area of a triangle, area equals 1/2 base times height, then in this situation, the base would be that c, and the height would be this b sine A. And so when I substitute that in, area equals 1/2 c b sine capital A. And really the way we're going to write that is A equals 1/2 BC sine A. And the nice thing about this is it's very pattern oriented. So whatever angle I have, I use the non-opposite sides to make this formula. So A equals, if the angle I had was the angle B, it would be 1/2 AC sine capital B. And if the angle that I had was angle C, it would be 1/2 AB sine capital C. And so when we're in a situation where we would maybe be using the law of cosines again, we have an angle and the two sides that make that angle, then we can use one of these formulas as well. So here's just an explanation of going through that same thing. I'll have it on the slides if you want to look at it, but I think that's good to go. And then here it is, you know, kind of as our key concept. The area of a triangle is 1/2 the product of the lengths of two sides and the sine of their included angle. And so any version of that works, just knowing that it's 1/2 AB sine C, 1/2 AC sine B, or 1/2 BC sine A. So I'll leave that with you. If you need to write it down, pause this. Otherwise, I'm just going to move on to this next problem here. And this is to find the area of triangle ABC to the nearest tenth. And so you'll notice we have angle A is known, little c is this side, and little b is that side. And so the version that we're going to use for the area formula is area equals 1/2 BC sine capital A. And then, you know, these are pretty straightforward problems. We just plug that in. A equals 1/2 times 39 times 52 times the sine of 25.89 degrees. And then take a moment. You can do that on your calculator. Please make sure that you are practicing these on your calculator so that you can iron out any issues before you have to take a quiz or a test or whatever the case may be. And then A is approximately 442.8, and since it was in inches, square inches. So that is how to find areas of things. And then the next thing that you're going to do is the teacher should be giving you a handout of the multiple choice problems for 4-7, and there are some problems for you to try there, and then you can go over those at the end of the hour, and then you should turn that paper in on Friday when you take your quiz. And if you don't have time to go over them today, just ask that the teacher kind of show those answers before you take your quiz on Friday. And those answers should be on the main SmartNote file for my absence. And so that is everything that I have to say about this. And so now you're doing these problems, and then you're going to check them over.